In this video, I'll be demonstrating to you the basics of using the Wireshark Packet Sniffer program to capture frames from your network interface card. The first thing I want to do here is at the command prompt, I'm going to go ahead and show you that I have an entry in here of 192.168.1.80 in my ARP cache. And so I'm going to delete that. So let's redisplay the ARP cache now, make sure that that is gone. Okay, so you can see now that the 192.168.1.80 is no longer in my ARP cache. So then the next thing I'm going to do is I'll fire up Wireshark, start recording or capturing the activity of my network interface card, and we'll do a little ping of the address that I just deleted there, 192.168.1.80. And so what I want you to see is that there will be an ARP request sent out then to that computer to get its MAC address, and then that computer will respond back with an ARP response, and then after that occurs, then we'll have the 4 ICMP packets. ICMP is the Internet Control Messaging Protocol that is actually the underlying packet structure that gets sent out every time you do the ping command. And so we'll capture all that activity, and then we'll go back into Wireshark and see the actual frames that are captured and take a look at some of the details. So let me go ahead and bring up Wireshark, and then I'll click on capture. I'll choose interfaces, and this is the interface I want to start capturing on. If you had multiple interfaces, you would see them listed here. You could select them individually. We'll go ahead and click start. You can see that activity starts right away here. And now let's go back to my command prompt. Let's type in ping 192.168.1.80, and we get our 4 ICMP replies back. Now we'll go back to Wireshark, go ahead and stop that capture and see if we aren't able to capture that activity. So when you look at the Wireshark interface, you can see that you have 3 panes here. The top pane underneath of the toolbar is the individual frames as they're captured, and then as you select these individual frames, in the middle pane you'll see is a details pane where you can actually view the contents of each of the frames as you select them. And I'll come and show you that here in a little bit greater detail in just a little bit. And then at the very bottom we see the hexadecimal value, and then to the right the ASCII value of the contents of the captured packets. So let me scroll up here, and this is the beginning of our capture. So let's scroll down, and you can see there's actually several ARPs going on here, but we're looking specifically for the request for 1.80, which is this one right here. So this is as soon as I typed in ping 192.168.1.80, the first thing that occurred was a broadcast, and in this source column, well, I guess we should identify the columns for you first here. The time column on the left here, this is in milliseconds, so it's the number of the frame and then the actual milliseconds it was captured at. Then the source column is where the message is coming from, so del 02 is my computer. And so then we have the destination column. It broadcast, so it sent out the ARP request to the entire network because it was looking for the MAC address of an IP. So it sent that message to every computer on my network asking, is this your IP? And only the computer that has the IP of 1.80 is actually going to respond to it. And then under the protocol column, you can see that is the actual protocol that was being used. In this case, that's an IP layer or network layer protocol, ARP. And then it kind of gives you a little description about what's going on there. So we were asking 192.168.1.80 what its MAC address is, and we said to respond back to my computer 192.168.1.202. So then the next frame right after that then is the response. So we can see that's coming back from my server, which happens to be a Dell server, and it's responding. It's saying I'm 1.80 and here is the MAC address that I have. So let's go back to this first frame here and go down now to the details. Notice the way that this is organized is in the same order from the top down. This would be the bottom up of the OSI model. So we have at the first entry the frame information, and then the second entry, this is the actual data link layer information. So you can see that it has the source MAC address, the A4BA-DB02FE15 here. That was the source MAC. This is the actual header that we're looking at of the frame as it was sent out onto the network. The destination MAC was all F's, so that's broadcast, meaning every computer is going to process it. They're going to receive it at their interface card at this layer. And then the next thing that it's going to look for is, if we go down a little bit further here to address resolution protocol, this is the network layer now, the protocol that comes at that layer. And the receiving computer looks to see, is the target IP address, does that match an IP address that's assigned to one of its interfaces? And of course, in the 1.80 computer is the only one that is going to actually then process it from that point. So let's go back now to the second frame here. Now you can see is the one that came back from 1.80. So this is the ARP response coming back. In fact, I forgot to show you. Let me just go back one frame here. When you look at address resolution protocol, notice that in parentheses there it says this was an ARP request. And there's a few other details we can cover here too, which is that the IP is version 4. That's 0800 represents IP version 4 that's being used there. And then the operation code of a 0001, that indicates that this is an ARP request. Okay, now let's go back to the response. So now again at the network layer, here's the ARP and the reply. Of course, we look at the MAC layer, or the data link layer, the MAC sub layer. We can see that it's coming now from this other MAC address, which is my Dell server, and responding back to my MAC address. And it's a type ARP packet too, so an 0806 is indicating it's a type ARP. It's a reply. Again, it's IP version 4, and you can see reply now is a 0002 as far as the operations code. And it just is returning then the MAC address back to myself or my interface so that that can be stored in the ARP table. So that's the first thing that has to occur for any communication between two interfaces to work, is that they have to know each other's MAC address. So if that's not already in their ARP table, then an ARP request is sent out and ARP response comes back. Now when we ping, we're sending out ICMP packets, and so the next one we see here is a ping request that comes from 202 and goes to 80, and then right underneath of it is a ping response, which is 80 responding back to 202. So you can see here request and reply. If we select the request frame, it works pretty much the same way. We've got Ethernet 2 being used at the data link layer. We've got the destination address. We now have the MAC address that we're sending to, and here's the source address. Then we move up to the, and by the way, here's the type at the data link layer. So this would be the LLC sublayer. It indicates that IP is the protocol operating at the next layer up. And so here's the next layer up is the network layer, and so we have the internet protocol operating here. We can see the source IP address and the destination IP address, and then also internet control message protocol, or ICMP, was being utilized here, because that's what the ping does. Sends out these what are called echoes, and this is a ping request. And it also sends out a little bit of data, which is just a random string of numbers. So that was the request, and then we click on the frame that's the reply, and you can see again that it indicates the source IP address then is 80, responding back to 202, and that it's a ping reply or an echo reply, an ICMP reply, and again it responded back with a little bit of data there. So what I want you to kind of get a feel for here as you use Wireshark is to capture some frames and identify the different protocols that are being used. You can see we even have some UDP here, which would be at your transport layer. So now we've got the data link layer, we've got the network layer, and we've got the transport layer, which is where our port numbers are, source port and destination port, which identifies the actual applications or programs that are running on each end of the communication process. So the source port would be the device or the program that is sending the message out on the network, and then the destination port is once it arrives to its destination, program should be processing the message as it's incoming to that system. And so again, the point is that this Wireshark is actually showing you each layer of the OSI model and how this information is encapsulated into frames. And so it's kind of reversed. You've got the upper layers starting from the bottom working your way up. You've got the upper layers working your way down towards the bottom layers. And so just kind of finish the thought here. We've showed you the first ICMP. Every time you do a ping, there's 4 requests sent out, so you should get 4 replies back. And so here's the second set of request and reply. Here's the third set of request and reply, and then here's the fourth set of request and reply. And then obviously there's a lot of other traffic that's going on here at the same time. I just want to focus specifically on those so that you could get a good explanation. Some of the other stuff that I can see here is like SMBs. This is server message blocks. So when I actually want to establish a session, see if I come down here to the details, you'll see it's a NetBIOS. This is a Microsoft specific protocol for file services. And so some sort of a file request was going on there. And so it established a NetBIOS session, and then it uses the server message block protocol to actually communicate probably with my file server on the network, doing some sort of an exchange. So this is where you can kind of get a feel for the different protocols. You can look at the details of the information that's being conveyed between two machines. You know, you can see the source IP, the destination IPs. You can see the MAC addresses that are being used. So you know, that's a little introduction for you. This is, at this point in time, really all you need to know about Wireshark, but later on you can use this to your benefit to troubleshoot networks and kind of identify problems that are going on, because you would look for certain messages that are maybe being sent out on the network that either shouldn't exist to begin with. So maybe there's some kind of a virus that's, you know, sending out messages onto your network and shouldn't be, so you can track down where they're coming from. You might also see a conversation between two different devices and realize that there's something wrong with the format of the message. There's a lot of things that you can do with this tool, but right now it's just it's a good tool for you to use to kind of get a beginning understanding that when we talk about the OSI model and this encapsulation of data from the upper layers and passing it down finally to the data link layer and forming a frame, you can actually see all of that information then that exists inside of the frame and start dissecting it so that you can understand it a little bit better.